Okay, my dear children, today we are going to discuss factorization of polynomial. The exercise 2.4 is completely based on this concept, factorization of polynomial. Let us take an example. Tell me the remainder. What will you get here, remainder? I am dividing 70 here. I am dividing 70. How many times 7 table goes in the 35?
Sir, 5 times.
Yes, very good. 7 5 is 35. What is the remainder here?
Sir, 0.
0.
Yes, very good. Here, can we say that? Can you say that 7 is a factor of 35? Can you say that 7 is a factor of 35 or not?
Yes, sir.
Yes, sir. Yes, sir.
Because after dividing this number 35 by 7, we got 0. Please connect this remainder concept, my dear children. Remainder concept to say the factor of a number. If we are getting remainder 0, we say that here this is a factor of 35. Yes or no? Remainder is 0. Therefore, we say that 7 is a factor. Now let us take example 2. Example 2. Divide the number 352. Divide the number 352 by 7. What will you get remainder? Can you tell me?
2.
Yes. Tell me here, divide quotient for 7 2 times. Yes or no? 7 2 times. We have to carry
One
down this
just-
number 2. But here we cannot divide this number by 7 because this is a smaller number, and moreover there is no any digit to bring down. There is no any other digit to bring down. There is no other digit. So here we keep 0 and we have taken this number as remainder. So 720 times, then we get a remainder 0. In this case, can you say that 7 is a factor of 352? Can you say 7 is a factor of 352?
No, sir.
No, sir.
Why?
So
Why
because
are-
the
why are
remainder
the-
is
Because
not
the
0.
remainder is not 0.
Yes, very good, very good. Here, remainder is not 0.
Sir, in the quotient part,
Remainder is 2.
5 or 35, right? Sir, 5 only now will come.
Sorry, 7 5. Okay, 7. 7 5 times. Very good. Srijana, 750 times. 750 times. Okay, 750 times. 750 times. Then it goes in 352, 750 times. Then remainder is 2. So here we did not get remainder 0. If you are not getting remainder 0, then we cannot say this number 7 is a factor of 352. Yes or no? Therefore, 7 is not a factor of 352. So here to say the given number is a factor of the second number, which part is taken important, by which concept we have said the given number is a factor, this given number is not a factor.
So by the remainder.
Yes, very good. By giving the more importance to the remainder, you said this number is a factor of this number and this number is not a factor of this number. The same concept, we can apply the same concept to the polynomials also. We can apply the same concept to the polynomials also. Okay, my children. So, suppose P of x, they will give a polynomial P of x. We have to check whether the polynomial, a linear for polynomial, just we start with a linear polynomial, we extend for the other polynomials also. We extend this concept for the other polynomials also. Suppose this is a polynomial and this is another linear polynomial. Suppose if you are dividing x minus a, we divide this polynomial P of x by x minus a, we get remainder 0. If you divide this polynomial P of x by x minus a, what is the remainder? Can you tell me? By theorem, can you tell me what is the remainder? If you divide a polynomial P of x by linear polynomial x minus a, what is the remainder? Can you tell
Sir,
me?
it can be any remainder, sir.
Sorry?
Sir, we can't determine the remainder without P of x, no, sir.
Previously you have learned what is the remainder when you divide a polynomial by x minus a. What is the notation? Of a. This is the remainder. In the remainder theorem, you have learned P of a
Yes,
denotes
sir.
the. See here, P of a. So remember this point, P of a denotes the remainder when P of x is divided by x minus a. You forgetting these points, my dear children? Don't forget. I asked the same question. Based on the same sentence, I asked here the same question. If you divide a polynomial P of x by x minus a, what is the remainder? P of a is the remainder. Okay. Suppose if P of a, if P of a value is 0, if P of a is 0, then we say that x minus a is a factor of P. If this is remainder theorem, by taking the remainder theorem in the reverse order, if P of a is equal to 0, that is if the remainder is 0, then we say that x minus a is a factor of the polynomial P of x. Because we got here remainder 0. What you said here in this case, this example, what you said, if you get remainder 0, you said here, this is a factor of this number or not. Same concept here also. If you are dividing a polynomial P of x by x minus a, actually it is a notation P of a. It is some value. P of a is some constant. If that constant is 0, then we say that x minus a is a factor of P of a. Otherwise, we say that it is not a factor of P of x. Understood this point, my children? If P of a is not equal to 0, that is, if remainder is not equal to 0, if P of a is not equal to 0, then we say that x minus a is not a factor of P of x. Understood this concept, my children? How do you say a linear polynomial is a factor of the given polynomial? You have to find the remainder. As you have found as you have found P of A in the previous exercise, you also has to found P of A. If P of A is equal to 0, then we say that x minus A is a factor of the polynomial. If P of A is not equal to 0, if P of A is not equal to 0, then we say that x minus A is not a factor of P of x. Understood this concept, my dear children? Understood this concept? So
Yes.
here
Yes,
I am writing the statement of factor theorem. I am writing here statement of factor theorem. If P of x, this definition is already given in the textbook at page number 40. At page number 40, it is already given. Okay, just I am writing the same statement here. If P of x is a polynomial, if P of x is a polynomial of degree it's okay, because of some network issues, because of some climate, network is not okay, not well. Degree n greater than or equal to 1. But don't worry, I will post this video. I post this class in video format. Okay, my children. If network is not,
Okay, sir.
if a network is not supporting us, then screen will not be clear. Letters will not be clear to you. Sometimes it will not be clear to you. It may be blur. Letters may be blur. Yes or no? Sometimes letters may be blur. They will not be clear to you because of network issues. But don't worry about this issue. I will post this video in the Google Classroom. I am recording this class and I will post this video in the Google Classroom. Don't worry about it. Then in the video, the letter will be clear because it is not network issue. Okay. I think network issue cannot affect this video. I think. Okay, my dear children. So
Okay, sir. Sometimes it is clear, sometimes it is getting blurred, sir.
only because of network issue, only for because of network climate. Since the climate is also very cool, that is why network may be some issues. Network connection is also difficult. Greater than or equal to 1 and okay, thank you, my dear children. And A is, and small letter A is any real number, any real number, then x minus a, x minus a is a factor of, x minus a is a factor of P of x if P of a is equal to 0. If P of a is equal to 0. And second point, P of a is equal to 0. P of a is equal to 0 if x minus a is a factor of P of x. It's about factor theorem. Here, whatever I explained this sentence P of a is equal to 0, that is, if remainder is 0, then x minus a is said to be factor of P of x. Same point here. If P of a is equal to 0, then x minus a is a factor of P of x. Conversely, If P of A at P of A is equal to 0 means remainder is 0. If x minus A is a factor of x. Yes or no? If 7 is a factor of, in this example, as is a factor of 35, what will you get the remainder here? 0. Yes or no? If the number 7 is a factor of 35, then what will you get remainder in the long division? 0 only. Yes or no? Same concept in the conversely, the statement is given. This is a converse. If x minus A is a factor of P of x, then P of A is equal to 0, then remainder is 0. If the given number is a factor of the second number, then what will you get remainder? 0. If it is not factor, then what will you get remainder? Non-zero, some other number other than 0. Non-zero means other than 0. Understood this point, my children?
Understood, sir.
This reminder concept is very useful in verifying. Very good, Mahima. Very good, Srujana. In verifying or in checking whether the given linear polynomial is a factor of the given polynomial or not. Remainder. All the concept is based on the remainder only. If remainder is 0, then we say that it is a factor. If remainder is not 0, previously also I told you, I wrote to the sentence clearly, P of A throughout this chapter, polynomials, there are two meanings. Do you remember that point here? Two meanings are there. I wrote here clearly, P of A. P of A has two meanings. What is the first meaning? The value of P of x when x is equal to A. Previous class, 19th of this month. Okay. P of A has two meanings throughout this chapter. You have to remember these two meanings. P of A means sometimes we take its meaning as the value of P of x when x is equal to A. Second meaning, the remainder when P of x is divided by x minus A. You have to remember these 2 points. Whenever you are getting P of A, P of some number, P of some constant, A means here some constant, then that notation denotes the value of P of x when x is equal to A. And another meaning, second meaning is it is a remainder. P of A is a, that is why I asked the same question here, my children. If you divide P of x, by x minus A, what will be the remainder? In the notation form, you have to tell P of A. In the notation form, tell here P of A. This value may be 0, sometimes the remainder may be 0, like this. Sometimes maybe 0, you get remainder 0, and sometimes you get non-zero. It may be any number, maybe 1 by 2 or 3 by 2 or 2 or minus 2, some any real number than 0. Understood this point, my children?
Understood, sir.
This is about a factor theorem. So when do you say a linear polynomial, when a linear polynomial x minus A is a factor of P of x, we have to find out P of A. If the P of A value is 0, then we say that x minus A is a factor of P of x. Otherwise, we say that it is not A. If P of A is not equal to 0, then we say that x minus A is not a factor of P of x. This concept is very, very useful. These two sentences. Okay, my children. Now, next point. There are two different cases, especially factorizing a polynomial, factorizing a See here, my children, we are going to discuss these points. Factorizing a quadratic polynomial. What is meant by a quadratic polynomial? Tell me. What is meant by a quadratic polynomial? Tell me what is meant by a quadratic polynomial. Tell me, my dear children. Any one of you?
2.
So
Any
the
one of
degree
you?
of the polynomial is 2.
Very
The
good.
degree
Very
of the
good.
polynomial is 2, sir.
Very good. What
Degree
about
of the
other children?
polynomial will be 2.
At least repeat the same answer. At least repeat the same answer. Someone told the answer. At least repeat the same answer. My dear children, inculcate the habit from your mouth. From your mouth. I want to listen that same answer. The degree of the polynomial, yes, should be 0. Very good. What about Nikita, Rahul, Yehona Singh, Trinson, Anmol? At least repeat the same answer, my dear children. Quadratic polynomial means the polynomial of degree is 2. This is the first case. This is the first case. Second case, factorizing a cubic polynomial, or what is meant by cubic polynomial?
So the degree of the
The
polynomial
So
degree
the
of
degree
3.
of the polynomial is 3.
Very good. Degree of the polynomial is 3. By quadratic,
the degree of
The
the
degree of the
So
polynomial
polynomial is 4,
polynomial
sir.
is degree 4.
yes, degree of the polynomial is 4. Or any polynomial of degree greater than 4. Less than 4, we have given some particular names. Degree of the polynomial is 1, that is called a linear polynomial. If the degree of the polynomial is 2, it is called a quadratic polynomial. If the degree of the polynomial is 3, it is called a cubic polynomial. If the degree of the polynomial is 4, then it is called biquadratic. After that, if the degree of the polynomial is more than 4, we are not giving a particular name. That is enough. In a higher classes, you may learn. That is not an important point here. Okay, names of the polynomials are not important. Whose degrees are greater than 4. Up to here, just to learn these terminology: linear, quadratic, cubic, and biquadratic. Okay. Now, in these two cases, we are going to find factorizing. Since the degree of the polynomial is 2 for a quadratic polynomial, there are only 2 factors. At most, 2 factors will be there. For a cubic polynomial, as the degree of the polynomial is 3, it has at most 3 factors. At most 3 factors. Okay. Just I will write that point here. Okay. In the next page, I will write the utmost number of factors. The utmost number of factors of a given polynomial. For a quadratic polynomial, it has at most two factors. It will not have more than two factors. It will not have more than factors. Similarly, by a cubic polynomial, for a cubic polynomial, it has at most how many factors will be there? Three factors. For a biquadratic, what is the degree of this biquadratic polynomial? 4. So it has at most 4 factors. It does not have more than 4 factors. Remember this point. Remember this point, my children. Based on the degree of a polynomial, we can say that the utmost number of factors of the polynomial. We can say the utmost number of factors of the given polynomial is based on the degree of the polynomial. If the degree of the polynomial is 2, it has at most 2 factors. If a cubic polynomial is given, it has at most 3 factors. If a biquadratic polynomial is given, it has at most 4 factors. Okay. Okay, my children.
Okay, sir.
What's
Okay, sir.
utmost? What is meant by utmost? I will explain you. What is meant by utmost factors. See here. Suppose first I multiply these two. I multiply these two polynomials. Then what can you tell me? X into x plus 3. Okay. Do you know how to multiply a polynomial by another polynomial? Plus 2 x plus 3. Then what will you get? X plus 3x plus 2x plus 6. Here these two terms are like terms. These two terms are like terms. Finally, what will you get? X square plus 5x plus 6. Now tell me which type of polynomial this one? Quadratic or cubic or biquadratic?
So quadratic.
So quadratic, sir.
Quadratic. So for polynomial, which are the factors? What are the factors? X plus 2 is one factor, x plus 3 is another factor. Yes, x plus 2 is one factor. By multiplying these two numbers, we got this polynomial. Yes or no? So we can say that the first polynomial is a factor of this polynomial, and the second polynomial is also a factor of this polynomial. Okay. Factors of x square plus 5x plus 6. See this example. See this example. Multiply these two polynomials and tell me. Yes or no? X plus 5 into x plus 5 means x plus 5 whole square. Yes or no? A plus b whole square. A square plus 2ab. 2 into a into b plus b square. Then what will you get? X square plus 10x plus 25. Okay, my children. For this polynomial, what is the polynomial here? This is a quadratic or cubic or biquadratic polynomial?
The quadratic.
Quadratic polynomial. For this polynomial, what are the factors? Can you tell me?
X square, 10x, 25.
What are the factors?
Sir, sorry, sir. X plus 5 and x plus 5.
See here. See, first polynomial and second polynomial both are same. Yes or no? In this case, we don't say x plus 5 and x plus 5 are factors of x squared plus 10x 25. We don't repeat the same. So simply we can say that here x plus 5 is a factor. It is a repeated. Whole square means it is repeated factor. For this factor, for this polynomial, how many factors are there? How many distinct factors here? Here, these two are two distinct factors, two different factors. For this polynomial, these are two different factors. X plus 2 is one factor, x plus 3 is another factor. Whereas in this case, in this example, for this polynomial,
same.
we have known both are same. So in this case, we say that only one factor, but it is repeated factor. Understood? Here, at most, how many factors for this one? 2. But for this, how many factors? Only one. Don't say 2. Here, in this case, it has 1, but it is a repeated factor. Understood this point, my children? X plus 5 is a repeated factor. It has no second factor. The second factor is also same, first one only. That is why we wrote here repeated. X plus 5 is a repeated factor. Understood this point, my children? Right.
Understood, sir.
Now the time is 12 past 32 minutes, my children. Now you can leave the meeting. Take care of your health, my children. We continue this concept in the next class and get ready for the test on Monday. Yes or no? Monday.
Yes, sir.
Yes, sir.
Monday on polynomials. Polynomials, which chapter? We are going to write polynomials. Okay.
Okay, sir.
Thank you, sir.
Okay, my dear children. All my dear children, stay at home, stay safe.
Thank you, sir. Thank you,
Sanitize
sir.
your hands frequently and maintain social distance of 2 meters from others. And do your work sincerely and seriously. Thank you all, my dear children. Thank you.
Thank you, sir.
Thank you, Sri Darshan. Thank you, my dear Sri Darshan. What, my dear Janesh? Still you are online? Janesh, why did you stay back online? Still? My dear Janesh and Anmol, you are not responding to my questions. I will remove from the meeting. What, my dear Anmol?